Hello grade 12s. Today I'm looking at the IEB paper 2 from 2021, the mechanical paper, and I'm going to be looking at the CAM drawing today. Now for a number of years they have previously only had one Loci question, and that was the CAM, but in 2021 they've included the Loci mechanism and the Loci Cam, and so there's a bit of a split in the mark allocation. So let's go ahead and take a look at the CAM question 2.2 in the 2021 IEB paper 2. Here is question 2.2, the CAM question for this paper. Now, because the mark allocation is a little bit less at 25 marks, we can expect a certain amount of the information that will have been done already. So in previous years, things like labeling the displacement graph, putting in the scale, doing the simple harmonic motion would have been drawn separately and would have counted for marks. But because this year the mark allocation is only 25, because they have got two Loci questions, a whole lot of the information is given. So part of your displacement graph has been drawn, the labels have been included, they have drawn the follower for you, they have drawn the camshaft for you, put in the hatching, and put in the direction of rotation. So a lot of information has already been given, because this question is only counting 25 marks. With a roller-ended follower, what we always need to remember that where the points get projected to the center line and transferred to the angle, wherever they go is to the center of the roller. So each time we plot a point, we then still have to draw probably a semicircle just to give you an idea of where the roller would be. So that's very important with the drawing, is to make sure that we remember that when we plot our points, we still have to draw part of the roller. Now let's go along and take a look at what we're going to need to do to finish off the displacement graph. So when we've read the instructions here, this has been given the simple harmonic motion. Now it's telling us that from 90 to 135 the follower is at rest. So let's put in that information. Now 135 is between 120 and 150. They're giving us the scale is 8 millimeters. So what we're going to do is mark off 4 millimeters, which will give us the measurement to 135. So there is 135, and our graph is then at rest, and there is that point. Then it tells us with uniform motion from 135 to 180, drives us 18 millimeters. Now because they have given us this displacement graph, I would feel that chances are is that the measurement from there to the top is 18 millimeters, which we've got. So from there to 180 is the rest of the shape. So there is 180, and there is the rise. Now it's saying from 180 to 360, the follower returns to the original position with uniform acceleration and retardation. So what we're generally looking for with uniform acceleration and retardation is equal measurements vertically and equal measurements horizontally. So if this is my start point, there's 0, 1, 2, 3, 4, 5 and 6. I've got 6 divisions, so what I need to do is divide this height into 6 equal divisions. So what I'm going to do is just check my measurements here. So my total rise is 38 plus 18, giving me a total rise 38 plus 18 is giving me a distance of 56. Now that measurement is not divisible by 6, so what I need to do is use the line division method and mark off 6 equal measurements. Now this is my center here, so you could project it here, though it's possibly going to be better to do it out here on the side. So line division construction involves us taking 6 equal measurements. So I'm making 10mm divisions on this line at any angle, and then what we do is we line up the last point with our last point of our displacement graph. So there is the last point, and we now put the 2 set squares together and slide them along. Okay, there are those measurements, which I now want to transfer to the center line. So if I've got 6 divisions, I want to take these measurements across to my center line here at 3. So each of these height measurements would be equal. Now, a test for our accuracy is when we take our top point and we line it up with our bottom point, and that's going to go through our center here over there. So I'm going to label off my heights as well. So this is my 0 height, first, second, third, fourth, fifth, and my last height. And now we project lines from our corner. So from the corner, we're going to project to height level 1. Where that intersects the vertical line 1, that's giving me my point. I go to height level 2, and I'm projecting that line. Where it intersects with the vertical line 2 gives me my point. Point 3 is already found. I now go to the other side for the retardation side. So from the corner to height level 4, where that intersects the vertical line 4 gives me my point. From the corner to height level 5, and I want to find where it intersects the vertical line 5, and there are my points. Now, for accuracy, the middle 3 points should line up, and then we curve 0 to 1 and 1 going to 2, and the same type of process on the other side. And there I have my simple harmonic motion finding those remaining points. Okay, I'm now going to label my different divisions. Now, if our direction of rotation has been given as anti-clockwise, what we need to do is label clockwise. So here's 0, that will make this 30 We do need to add in some extra points here, so at 15, 45 and 75. Which we will do using our 2 set squares. So there are our 2 set squares together, giving me my angle here at 15. My 75-degree angle will be the 45 here. And there is the 45-degree angle. Okay, so all my points are now labeled around my shape. And now it's a matter of plotting the points by taking where they are hitting the vertical divisions across to the vertical line, and then using my compass to take them around to their angular displacement. I'm going to take my points across here now. So here is 15 degrees, and I'm making a mark there and labeling it. Let's go to 15. That is going to 30, and I carry on, 45, 60, 75, and 90. Now 90 goes all the way from 90 to 135. Now I need to transfer those across with my compass. Please remember, we always take our heights to the vertical before we transfer them to where they need to be. So here I'm taking my distance at 15, lining up my compass, there's 15. Remember, at that point 30 is the actual point there, and we always need to draw the semicircle of the roller after we've done this point. There's 75. Here is 90. Going to 135. So I've got to put an extra division in here to find where 135 is. And so here's my 135 division. Okay, so there are those points over there. I have projected my remaining points across here. There was 210, 240, 270, 300 and 330. This is obviously at 360. So transfer those points across to where we need them. So I know there was 180. I needed to take across 150. There was 150. 180 is at the edge here. Our next point is 210. 240. Here is 270. 300 I'm going to now. And 330. Now let's remember from each of those points I now need to draw the roller. So what I'm doing is setting the size of my roller, get the diameter of my roller, and at each of the points I've plotted now, I'm happy to draw a semicircle because that's going to give me an idea of where my cam profile will be. So please always remember this about your roller follower, as we now need to put in from the point that we found, we must now draw in the roller. Okay, I seem to be missing my point here at 180. Just need to go back and check where that was. I just need to check where my 180 point was. Sorry, the 180 point was at the end here. So there's my point. Now with your flexi curve or French curve, you want to go and draw tangents to these circles. Remember, it's not necessarily at this point where you will find your tangent. So if I look here, particularly here, that's where the edge of that circle is, so that's not going at the exact division. And there we have our drawing of the 2021 CAM profile of the IEB paper 2. If we just check things, the graph was for 6 marks, so we didn't have too much there. We had the uniform motion to that point and uniform motion, so a lot of the marks would be coming off these points for the the uniform acceleration and retardation. Then we've taken the points across and plotted our points, giving us 14 points. The Loci on the construction, so putting in our divisions, the line division method on this side, and projecting our points, 4 marks. Okay, the direction and the divisions. Well, the direction was already given So we just needed to make sure that we labeled it correctly, going in the opposite direction. And there we have the completed drawing of the cam profile, IEB paper 2, 2021.